So if you look, like if you, let's just say you look at 1. If you look at all the x values, one of them repeats, the 2 repeats, and they have a different y. So that one is not a function. Go to the second one, look at all the x values, they don't repeat, so that is a function. Go to the third one, look at the x values, they don't repeat. Oh, so that one works. Oh, but you're missing the pairs, right? Because there's 4. And then the last one, look at your x values. They don't repeat, so it works. So the third one didn't work just because you're missing. Like there's 4 points in A and there's 4 points in B, so you got to match them.
So yeah. It has to be like all 4 of them in this set?
Correct.
Okay.
Yeah. And you won't really see it like a test question for the match for the like what goes with what would be more like here's your coordinate points. Do they represent a point? Do they represent a function? All right, so I assume you're good on A. Yes? And B? Because you got those right, you're good? Okay, so then C, you have to do the g of x minus the g of 2. So g of x is your whole original one, which was 7t squared minus 4t plus 5, minus what you got for the g of 2. And what you got for the g of 2 was 25. And then you just combine those like terms. So 7t squared minus 4t minus 20. Yeah, so you're just combining the two together. Which is like when we get into, I think it's 2.6, that we actually do a lot of that stuff. We're going to do more with the function notation.
Wait, so what is this GT? Does that mean?
GT would be like plugging t in, but the t is already there, so it is the original. G of t is what they give you. You don't have to alter it.
Got it.
Yeah. All right, so it said find the values of x through which f of x equals g of x. So x to the 4th minus 32 x squared equals 32x squared.
So would you just divide by x?
You can't divide because then you lose the 0. So you have to move it. So you'd subtract. And I get x to the 4th minus 64x squared equals 0. I can take out the x squared, but it still has to be one of the answers. So then this is difference 2 squares. And then there would be 2 zeros because it would be plus and minus 0, but you only need it once. Negative 8 and positive 8.
That looks a lot more sensible than the whole thing I did.
Yeah. You can't cancel out variables because you lose an answer. All right, so 2b is so it's like part 2 of 2 is domain. So domain is all, by definition, it's all of the values of x that you can use. So all of the x values of a function, okay? If you're given a set of coordinate points, then the domain would be all the x values. If you're looking at a graph, it would be all the points from left to right. So if I had a graph that was arrows in both directions, like this way to this way, that domain would be all real numbers because it points to the left and it points to the right. If I had a graph that had a solid dot and then pointed to the right, then it would be from this x value to positive infinity. So we're going to read it from left to right with a domain. And then we're also going to learn how to find domain from an equation. So 3 different ways that you'll find domain. If you're actually given the coordinate points, it's all the x values. If you're given a graph, you're going to give the values that the graph covers from left to right. And if you're given an equation, I'm going to teach you some things to look for to find domain. All right, so if you're given an equation, then the default of the domain is all real numbers. There are 3 exceptions. So again, default all real numbers, which in interval notation is negative infinity to positive infinity. That's the default of any equation. But there are 3 special cases. The first is if there's a variable in the denominator. If there's a variable in the denominator, then what's there, right, what's in the denominator can't be 0 because it would make the whole thing undefined. So to find that restriction, we set the denominator not equal to 0, and that's what x cannot equal. So kind of like we do when we solve with our extraneous roots. The second case is if there's a variable under a square root. We cannot square root a negative number. So we set whatever's under the root greater than or equal to 0, and that restricts our domain. And the third is the combination of the 2, a variable under the square root in the denominator, And then it can't be 0, and it has to be greater than 0. So now we set what's under the root greater than 0 instead of greater than or equal to. If none of those 3 cases happen, then my domain is all real numbers, or negative infinity to positive infinity. But obviously, we're going to deal with a lot of things in which those restrictions are going to happen. All right. So start with example 1. Says find domain of each function for this, right? So example 1 is giving me the coordinate points. Which of those coordinate points are going to be my domain? All the x coordinates. So 3, 4, 5, and 8. That's it. You're just listing the values of x that are there. Then from here on out, it's equations. So it is by default, again, all real numbers, but except if there's a variable in the square underneath the denominator, a variable in a square root, or a variable in the square root in the denominator. So if I look at 2, are any of those cases happening? No, this is an all real numbers scenario. Or negative infinity to positive infinity if it wants it in interval notation. So that just basically means I could literally plug any value into my x and I would be able to get an answer. There's no time when it would be undefined. And if you think about it, this is a line, right? It would cross through 1 and the slope would be negative 2 over 1. So this would be a line with arrows pointing left and right, which means, again, I would go to negative infinity to positive infinity. Go to 3. Variable in the denominator or under a root?
Yes.
Where?
Oh, never mind.
No, right? So what is this? All real numbers. Or negative infinity to positive infinity. Again, that would be a line, arrows pointing in both directions. Go to 4. Xavier.
So wait, how do you know which way the line is gonna go?
The slope, right? Down 2 and over 1? Yeah. How about 4? Variable in a denominator or under a root? Nope, all real numbers again. Negative infinity to positive infinity. 5? Variable in the denominator under a root? Nope, negative infinity to positive infinity again.
Which one the homework's gonna be like?
There's not a lot of those. Now we get to 6. Variable in the denominator or under a square root? Yes, this time it's in the denominator. So we say whatever's in the denominator cannot equal 0 because that's what would make it undefined. So x cannot equal 0. So if it asks for it in like words, that's what you're saying. All the real values of x except for 0. So you'll either see it like multiple choice. All values except 0. It might look something like that. If it's in interval notation, then it's all the values up to 0, but not including 0, and all the values after 0, but not including 0. So that's what a not equals looks like in interval notation. Negative infinity up to that number with a parentheses, and then that number to positive infinity. I can't remember, but I think the WebAssign does all the values except 1. But by the test, we'll be doing interval notation too. So you want to practice. Questions on those? All right. Go to 7. Same set of instructions. Is there a variable under the square root or in the denominator? Yes. I can completely ignore the 1 in the numerator. It does not have any impact. I can have a 0 on the top. But the bottom cannot equal 0, which means x cannot equal 5. So it would be all real numbers except 5 or negative infinity to 5, 5 to positive infinity. God bless you. God bless you. God bless you. That's it. You're not allowed anymore. Oh, it was a joke. I didn't really mean it. But good job. All right, how about 8? What's happening?
X can't equal.
Good. Denominator can't equal 0. So 2x cannot equal negative 1. Divide by 2. And x cannot equal negative 1/2. So from negative infinity to negative 1/2. and then negative 1/2 to positive infinity. All right. All right, same thing, denominator or variable in the denominator. So now this can't equal 0. Now what's different? This is different to 2 squares, or you can move it, square root it, but you got to do plus or minus. So now there's 2 values x can't equal, because x can't equal -1 or +1. So in interval notation, it goes from negative infinity to the smaller one, which would be -1, then the smaller to the bigger, then the bigger to positive infinity. So if it can't equal 2 values, you go from negative infinity to the smaller value, which is -1. It can't be that number, but then it can be all the numbers in between those two, so then the smaller to the bigger. And then again, it can't be the bigger, so then it has to go union from the bigger to positive infinity. So that's how you would do it not equals. You would just eliminate those two.
So I basically just add 0. Like 0 would be allowed there. But if
0, yeah, but even all the decimals in between there. So you're not saying they have to be whole numbers, right? It could be negative, it could be a positive 0.99999 and it still works. It's just as soon as it gets to 1, it no longer works.
So when you write it like that, that also excludes those 2 numbers and 0?
No, it just excludes those 2 numbers. 0 is part of that range, right? Because -1 to 1 would have a 0 there. That'd be from
Oh, right, 'cause it's how
-1 to 1. It'd be all the values in between there. And 0 would be in there. Because 0 is fine, right? I can plug 0 in, I still get an answer. Okay, now go to 10. Variable in the denominator. So again, x squared plus 4 can't equal 0. Can I factor that? You can't factor it because it's the sum of perfect squares, not the difference, right? So it can't be factored. If you try to solve it using even root, I'm going to square root and I'm getting an I. Okay, we are not doing i's here because those are imaginary numbers. We're not graphing them. So this is an all real numbers scenario. Negative infinity to positive infinity. So you won't ever restrict your domain with i's.
So we're gonna get an I, it's all real numbers.
It's all real numbers. Unless there was another answer too, like maybe there's a third.
Well, what if we rationalize that?
Why would you do that?
I don't know. You
Don't do
split
that.
it and you get negative.
You don't have to rationalize that though, because you only have to rationalize if there's a square root in the bottom. But you're not doing that. We're not solving these. We're just seeing what values of x you can't use. Yeah. Okay, and now 11, we get to a square root, right? And what did we say about the square roots? Can you have a negative under there? No, so greater than or equal to 0. What's underneath it? So I literally disregard the square root. The square root tells me how to set it up, but the square root is not part of my solving. I just say x has to be greater than or equal to 0. In words, it would be all real numbers greater than or equal to. And in interval notation, it's a bracket on the 0 to positive infinity. Okay, 12, we said x minus 3 is greater than or equal to 0. X would have to be greater than or equal to 3. In words, that's all real numbers greater than or equal to 3. In interval notation, it's 3 to positive infinity. All right, so for 13, 2x minus 1 has to be greater than or equal to 0. 2x greater than or equal to 1. X greater than or equal to 1/2. Bracket on the 1/2 to positive infinity. How do we do? Good? Okay. 14, 4 minus x has to be greater than or equal to 0. So if you add the x, or it depends. If you subtract the 4, then divide by -1, you got to flip the sign. If you add the x is on the other side. So either way, you end up flipping. So it'd be x is less than or equal to 4. So this goes negative infinity up to 4 with a bracket on the 4.
Okay, so if it's like if the number is the one that gets like greater.
Right, so if it's less than, it goes left, right? So we go to negative infinity.
Okay.
And if you need to draw your number line to see it, do it. Like if you need the visual on that line, do it. Everybody's good? Yeah? Okay, so now you've got the combination of the two. And this is honestly like there's one more thing that's harder than this, but this is where it gets a little bit trickier. When you start to put a square root in the denominator, now it has to be greater than 0, greater than or equal to 0 because of the square root. But then it can't equal 0 because it's in the bottom. So instead of saying greater than or equal to 0, we say it has to be greater than 0. So the rest of it's the same. The only thing that changes is the or equal to goes away if it's in the denominator. So x has to be greater than greater than 0, which means it's 0 to positive infinity with a parentheses. It can no longer equal 0 because it would be undefined. And then 16, same thing. It's in the denominator underneath the root, so 2x minus 1 has to be greater than 0. I'd get 2x has to be greater than 1, and x has to be greater than 1/2. So it gets a parentheses instead of a bracket because it can't include it anymore. Okay, so now this is where it gets a little bit more complicated because you've got more than one scenario happening, okay? So for 17, we're going to treat them separately and then figure out where the overlap occurs. For the numerator, what would be the restriction on the square root of x minus 1? How do I find that restriction?
Bigger than -2.
Greater, the top,
Oh,
right? Has to be greater than or equal to what?
0.
So x minus 1 has to be greater than or equal to 0, which means x has to be greater than or equal to 1. That's the restriction based on the numerator. With me so far? Now the denominator has what restriction?
Greater than 0.
It has to be greater than 0. It can no longer include 0, so its x has to be greater than -2. Now here's where I would recommend a number line so you can visualize this. The first one says it has to be greater than or equal to 1. And the bottom, I should have done it in a different color, but I'm going to do this in teal, says greater than -2, parentheses pointing to the right. Now, because this is one function, it's like an and statement. You have to pick where it overlaps. So I'm going to say it only works from +1 to positive infinity.
So it would just be x has to be greater than or equal to 1.
Correct. Which is a bracket on the 1 to positive infinity. So you're looking for where they overlap. It has to be true for both statements. Nope.
What happens if they're facing opposite ways?
Then it'd be no, that wouldn't work. Like you would have no numbers that could work, which that won't happen. Yeah.
That's 9. Bottom can't be.
All right, so go to 18.
Yeah.
Numerator greater than or equal to 0, so 2x greater than or equal to 1, and x has to be greater than or equal to 1/2. Denominator greater than 0, x has to be greater than -3. So 1/2 greater than or equal to, denominator greater than. And again, it's only where they overlap, which would be 1/2 to positive infinity.
So, can't I just do the numerator?
It won't always work in that order, though. It could be the reverse. Like if I put square root of x plus 3 in the numerator and square root of 2x minus 1 in the denominator, it's still the same answer, and it wouldn't be based on the numerator.
But we're not gonna have to graph anything for this.
You don't have to. Oh, like on your number line?
Yeah.
No, you're going to do, it's like other stuff that we're going to have to worry about the graphs. That's like the next section, but different. You're welcome. Now the fun bumps up a level. Numerator, greater than or equal to 0, right? So x is greater than or equal to 1. Denominator, greater than 0, not greater than or equal to, greater than 0. And now I've got a quadratic and an inequality. This is where we have to test points, right? So we solve it as though it was x squared minus 81 equals 0. Plus 9 minus 9, right? And I get -9 and positive 9. But I got to figure out from here which of the ranges works in this original statement. So I pick 0 because it's in between.
But isn't the square root of that just...
You can't square root it. Yeah. So I'd get 0 squared minus 81, -81 greater than 0. Is that true? No. So the denominator is from negative infinity to 9,
Wouldn't it,
and then 9 to negative 9, and then 9 to positive infinity. Wouldn't what?
wouldn't it just be like, it's greater than 9? That's it.
No. No, because it's squared. Remember, if you have the squareds and an inequality, you have to do the test points, and it's either in between or it's outside. Yeah. So now I have to overlap that with what I got from the top. So here's my answer for the bottom, with the one that's already shaded. And now this one says greater than or equal to 1. So 1's here, and it's greater than or equal to 1.
Wait, I thought negative 9 didn't, or which one did it work?
0 didn't work, so we shaded outside.
Oh,
Yeah. So now where's the overlap happen? From 9 to positive infinity. I mean, that's the hardest stuff. It's not that you don't know how to do that. You know how to do that in parts. It's the overlap of all of it. I'm going to show you one more thing because I think it shows up in the homework.
Wait, so it wouldn't be negative infinity comma negative 9 union?
No, because there's no other overlap here. It has to be the overlap of the numerator and the denominator. Think about what would happen. So here's the other thing. You could try it, right?
I can just do the numerator.
What?
But why can't they just?
Because if they're switched, which they can be, it doesn't work. Like, I could totally switch that question. Right? And my numerator would still give me the same thing, except that now they'd be greater than or equal to. So from the numerator, I'd get from negative 9 to positive 9 bracket on both. And from the denominator, it would be greater than 0. So it'd be from 1 to positive infinity. And it's still from 9 to positive infinity. So it's not just the numerator, it's the combination of the two. Okay, so here's what else you might see, and that is like a square root in the numerator, but then something in the bottom. So what do I do with the numerator? What's the restriction on that? Greater than or equal to 0, so greater than or equal to 1, that's that one, right? So 1 bracket pointing to the right. And then for the denominator, what's the restriction? Not greater than, just not equal to it, right? So x cannot equal 3, which means that 3, it would be like an open dot. It has to stop there. So that's where it gets tricky. It would be from 1 to 3, not including 3, and then 3 to positive infinity. Or in words, all real numbers greater than 1 except 3. So if you've got an inequality somewhere, but then you also have an ought equal to, which would happen if there's a square root in the top and a regular expression in the bottom, then you have to look for where your graph would stop. If that was like x can't equal negative 3, then I totally throw it out because I already have it restricted enough with the 1. It would not include negative 3. But if it includes something in the range of that arrow, then I have to stop my interval notation and not include it. Yep.
Wouldn't it be greater than or equal to? Or
Yes, greater than or equal to. You mean in the words, right? Yes. Thank you. Greater than or equal to 1 except 3. Questions? Not so awful, right? I mean, a little bit tricky there at the end, but nothing like some of the crap you've had to deal with. Yeah. Okay.